Hey, we're going to look at some topics in analytic geometry, and we're going to start off with lines. Today we're going to find the inclination of a line. It's another way of saying the slope, the angle between two lines on the plane, as well as the distance between a point and a line. Okay. So if we have a line on the coordinate plane and that line is not horizontal, so in other words, this here is a horizontal line, every line except the horizontal line has to intersect the x-axis. Okay, remember the x-axis is the one down here, uh, at one point and one point only. Okay, when it intersects that axis, it creates an angle, and we call that angle measured counterclockwise from the x-axis to the line. Counterclockwise from the x-axis to the line. Counterclockwise to the line. Okay, we call that angle the angle of inclination. Okay, so the angle of inclination, therefore, is a positive angle. We're calling it theta here, and it's going to be between 0, which would be a horizontal line, and pi, or 180 degrees. So a non-vertical line, okay, has an inclination of pi and the slope of m. Okay, therefore m is equal to the tangent of that angle of inclination. Let's just take a look at this. Let's say we have a line that is looking like that. Here is the angle of inclination from here to here. That is theta. And if we think about our slope of this line, right, we draw a little triangle. Okay, remember that slope is equal to rise over run. Okay, well, the rise here is this distance, which happens to be our y, or rise. And this distance is our run, which happens to be equal to our x value. Okay, so notice that for the angle theta, though, rise over run is the same as opposite over hypotenuse. I'm sorry, opposite over adjacent. Okay, well, rise over run is slope is equal to opposite over adjacent side, and that is simply the tangent of our angle theta. Okay, so our slope is the tangent of the angle. Okay, so we want to find the inclination of a line that has this equation. We know that the slope is equal to the tangent of the angle of inclination. So let's figure out what our slope is. What I'm going to do is solve this for y, basically putting it into slope-intercept form. And if I do that, I'm going to subtract 2x from both sides. I get 3y equals negative 2x plus 6. And then dividing everything by 3, y equals negative 2/3 x plus 2. Okay, so in this case, the slope of our line is equal to negative 2/3. And if we look at a graph of this, okay, we have a y-intercept of 2, and we're going to come down. We're actually going to intercept the x-axis at 3, and our line comes something like this. Imagine that being straight. And this is our line, 2x plus 3y equals 6. And I'm just going to extend this x-axis out. This angle here is our angle of inclination from the x-axis to the line. It's an obtuse angle in this case. Okay. So what's going to happen when we're taking the tangent, notice that it's negative. What we're actually going to be getting the tangent of in this case is this angle. Okay, and that angle plus theta is 180 degrees. Okay, but this angle is negative. So what we're going to do is we're just going to say theta is equal to 180. We want it to subtract. Okay, so I'm going to say plus arctan, or inverse tangent, of negative 2/3. And I want this to subtract This angle I know is going to be negative because it's got the negative tangent. It's going to put it in the fourth quadrant. It's going to be this angle. So in order to make this come out smaller than 180, which it has to do, the angle of inclination has to be between 0 and 180, we need to add the negative angle. Okay? So theta therefore equals 180 plus, and the arctan of negative 2/3 is going to be negative 33.7 degrees, or theta is approximately equal to 146.3 degrees. Okay, that would be our angle of inclination. Another way of saying the slope. So if we have two lines and they intersect in a plane, they create two angles. Okay, let's just draw a quick little diagram down here. Two lines that intersect like that. Okay, we're going to have this angle and this angle, and those are the same value, right? They're vertical angles, and they are acute. And then we have two obtuse angles. This one, which is equal to this one. Okay? We say that the angle between these lines is the smaller of these angles. Okay, so it's going to be this first one that we put in there, the acute angle. If we know the angle of inclination, okay, so let's say we have two lines here. This line has an angle of inclination of theta 2. This one has an angle of inclination of theta 2. If we subtract the smaller one from the larger one, so in other words, theta 2 minus theta 1, that's going to give us our angle between these lines. Okay? And here is a formula. If you have two non-perpendicular lines, if they're not intersecting at 90 degrees, okay, and you have both of their slopes, you could figure out the angle of them by using this formula. And this formula is actually just an expansion of tangent of theta 2 minus theta 1. Okay. That is an identity that we had looked at a while back, if you remember. But this is the formula that you need to know for figuring out the angle between two lines. All right, so we're given a couple of lines here. We want to figure out what the angle between them is. The first thing I'm going to do is figure out their slopes, right? Because I know that I'm going to write the formula, the tangent of the angle between them is equal to the absolute value of m2 minus m1 divided by 1 plus m1 times m2. Okay. So let's get m1, we have to solve for y. If I subtract 2x from both sides, I get negative y minus 4 equals negative 2x. I'm going to add 4, negative y equals negative 2x plus 4, and then I'm going to divide by negative 1 to get y equals 2x minus 4, and therefore m sub 1 is equal to 2. Doing the same thing here, 4y minus 12 equals negative 3x, subtracting 3x from both sides. Adding 12, I get 4y equals negative 3x plus 12. And then dividing by 4, I get y equals negative 3/4 x plus 3. And m2 is equal to negative 3/4. So my tangent of the angle is equal to absolute value slope m2 is negative 3/4 minus 2 divided by 1 plus m1 2 times m2. Okay, just plugging in the values. All right, so this equals negative 11/4 divided by negative 2/4. And it's still absolute value. Even though it's negative divided by negative, it's going to come out positive anyway. All right, if I simplify that, multiply by 4 over 4, cancel out my negatives, I get 11 halves. Okay, so the tangent of theta is that. So how do we get theta? We need to use the arctangent. Okay, so theta is going to equal the arctangent of 11/2. And if you plug it into the calculator, you're going to get theta is approximately equal to 79.70 degrees. Okay. We have a way of figuring out the distance between a point and a line, and if we have an equation for our line that is in standard form, if it's not in standard form, we have to put it in standard form. Okay, the distance between this point x1, y1 and the line, it's going to hit it perpendicular, because that's the shortest distance between the point and the line. If I don't hit it perpendicular, I might do something like this, and this blue segment is definitely going to be longer than this red segment. We don't want that. Okay. Here is the formula for the distance. This A, B, and C, as well as this A and B, come from the coefficients in our equation that is in standard form. And the x1 and the y1 come from the point. Okay, so it's a matter of remembering the formula and plugging in the values. Let's take a look at the problem. Okay, so we have the point 4, 1. Remember, this is going to be x1, this is going to be y1. We are not in standard form here. Okay, so I'm going to convert this to standard form. Y, I'm going to have to subtract 2x, so say negative 2x plus y minus 1 equals 0. Notice that this is in the right form. Okay, the x's and y's are in order, and my constant is here, it's equal to 0. Okay, so this tells us that a is equal to negative 2, b is equal to the coefficient of y, which is 1, and c equals negative 1. Okay, so now we could use our formula, right? Distance equals absolute value of a, x1, plus b, y1, plus c, all divided by the square root of a squared plus b squared. What's a b? Well, let's plug in our values. A is 2, so this is going to be the absolute value of distance of negative 2 times x1 is 4 plus b1 times y1 is 1 plus c is negative 1 divided by the square root of a squared plus b squared. Okay, well, let's simplify this. These cancel. I get the absolute value of negative 8 in the numerator, and the square root of a squared is going to be negative 2 squared, or 4, plus b squared is 1. So this whole thing equals 8 divided by the square root of 5. And if we want to rationalize that denominator, of course, we can multiply it by root 5 over root 5 to give us 8 root 5 divided by 5. Or if we want to evaluate it on the calculator, you're going to get approximately 3.58 units. We don't have the measurement here.